So, what is vector? Vector is a directed line segment. So this is a vector. It has magnitude, so length, and it has direction. And we will be the notation for vector that we will be using will be A there. Let's say starting point A and the end point B. And we can write vector AD and arrow at the top. Or we can name it, let's say, A with the squiggle underneath. I don't know why in special course it's not used as A with again arrow on the top like it's used pretty much everywhere, but in this course it's used like this, so we will follow that notation. And if two vectors have same length and same direction, it's the same vector. For example,
Hello?
let's see. So, if you look on the Cartesian plan, and we have one vector starting at 0, 0, and say 2, 1, 1, and that will vector OA, and we have another vector which starts, let's say, at 2, 3, let's say at point B, and it's finished at the point 4, 4. Not exactly. So this point 4, 4, we will see the vector OA and the vector BC, they have, as you can see, they have exactly the same length and they have same direction. So that is, because from 2, 3 to 4, 4, it's same distance from 0, 0 to 2, 1. And so it is not just equal, it's the same vector. So we can any vector, when we will be describing vector, we will be like moving it to the origin, starting from the origin.
Does the arrow mean it's going?
It direct. No, it has length. It's finished here.
So why is there an arrow? What is the
Direction.
arrow?
It has direction. Because we can have a vector this direction, that will be A, and a vector of the same length in the opposite direction will be minus A.
Okay.
That will be negative A.
Okay.
But direction matter. Vector has two: length, magnitude, and direction. So different direction, it's different vector, which in this case we can represent as negative A. We can describe this vector using matrices. We can write this vector when it starts from the origin, and we put the x, y coordinates of the end of the vector. So it will be 2, 1. So we can describe this vector 2, 1. That means always when we write vector, describe vector like this using the cone matrix, top is the x coordinate, the beginning is at the origin, and those are x and y coordinates of the end of the vector. Make sense?
Yeah.
No. With the vectors, we can do few operations. This year, and this will be learned 4 of them, and one more operation we will learn next year. This year we will learn addition, subtraction, multiplication by a scalar, and also we will learn about the dot product or scalar multiplication of vectors.
So next year we'll
And next year, no, there is no division of vectors, but there is a vector multiplication of the vectors, which you will learn next year, which no, all vectors has a lot of application to physics, and vector multiplication, so who doing physics 3-4 this year, and we will be doing special 3-4 next year, you will be using again right hand rule to work with the vector product of the vectors. So it will be easier for you as you've done it this year. It will be easier to operate with the vector products of the vectors. Now, addition of the vectors. There are two rules how we add vectors. In your textbook, it's for some reason pretty much only one. Triangle rule. If we have vector A and we have vector B, so to add them, we need to have, we're finding vector C equal vector A plus vector B. We need to place beginning of vector B at the end of the vector A, and then the result of the addition will be vector C will start where vector A starts and finish where vector B finishes. So that will be vector C equals vector A plus B.
I don't know what direction it has if it goes this way.
It is, as I'm saying, it's beginning where the beginning of vector A, this is beginning of the vector, this is the end of the vector.
I know that's the first vector. Oh, because it's
It starts at the beginning of A and ends at the end of vector B. Make sense? Parallelogram rule. Parallelogram rule. If we have two vectors with the which have the same beginning, like this is vector A and this is vector B. And we again looking for vector C equal A plus B. We can make parallelogram based on this, so we make parallelogram like this. Maybe a little bit longer this way. And the result of the addition of these vectors will be this diagonal of the parallelogram. That will be vector C equals A plus B.
how do you find it?
As we say, we have two vectors with the beginning at the same point. You make parallelogram. You know what a parallelogram is. You draw parallel lines, same parallel to this and same length, parallel to this same length, and this diagonal will be sum. You can see if you move vector B here, it's the same vector. And we will have A plus B, and we will get the same result. So pretty much it's the same thing, but it's sometimes easier just draw this and add them using the parallelogram. Subtraction of the vectors. Subtracting vectors, we using the fact that we already mentioned today that vector, if this is vector A, then this is vector minus A. So if you find in vector C, which is equal vector B minus vector A, we can treat it as B plus negative A. So we need to find the difference between, so we have vector B and we have vector A. Now, when we're subtracting, it's same as we do vector B plus negative A. Negative A will be this vector. This is negative A. And what will be the result of the addition of negative a and b? Because it's the same thing. If we do minus a plus b, what will be the result? If we add negative a and b, what will be vector c? If we add minus a plus b, we should have vector starting at the beginning of negative a and finishing. That will be vector c equal a minus b. So we're adding negative vector when we're subtracting one vector from the number. Now, if we're using the two-letter notations, which denoting the beginning and the end, so if we have vector, let's say vector AB plus vector BC, so vector AB plus vector BC, as you see, very important that we have end of the first vector is the beginning of the second vector, and the result will be vector AC. They will have that vector starts at the beginning of the first vector and ended at the end of the second vector. So AB plus BC will be AC. Make sense? Similar thing we can do with the subtraction of the vectors. If we have vector AB and we have vector AC, and we find in, let's say, AB minus AC. AB minus AC is the same as AB plus negative AC. This is will be vector negative AC or CA. And what will be the result of addition of those will be this vector. So that how we name this vector? CB. So as you can see, when we subtract vector AB minus vector AC, the resultant vector starts at the end of the vector which we subtracting and ends at the end of the vector from which we subtracting. So when we have AB minus AC, you can straight away say that it's vector CB. Make sense? How to do it? Now, multiplication of the vector by the scalar and parallel vectors. If we have, if this is vector A, the vector this vector, which has same direction by 3 times longer, will be 3A. So if you multiply vector by the scalar, so scalar means just a number, we will get vector of the same direction, just 3 times or whatever times longer. If you're using matrix notation, for example, we have vector 2, 5, and we multiply it by, let's say, 7. What will be the result?
14 and 35.
14, not over 14,
Yeah.
35. It will be same direction, but it will be 7 times longer than this. Make sense? So that pretty much all of the theory. One more thing, linear. One more thing, linear. Linear combinations of the vectors. If we have vector MA plus vector NB equal vector PA plus QB. What conclusion we can make from here? M equals P and N equals Q. Pretty straightforward. Now let's do some examples. Let's say we have a polygon of the vectors. And we have vectors A, B, C, D, E, and E, F, G, and H. So we have vectors which make this polygon. What will be the result of the addition if you do A plus B plus C plus D plus E plus F plus G plus H? 7, 8. What will be the result of this addition? 0. And there will be 0, but you don't write just 0. You need to put this with 0 vector. 0 vector, it doesn't have direction, it has 0 length. Now, what will be, can we put letters also? A, B, C, D, E, F, G, H. What will be vector in terms of A, B, C, D, and so on? What will be vector A, D equal? What will be vector A, D equal in terms of the A, B, C, D, and E?
A plus B plus C.
Yes, it will be A plus B plus C. A plus B plus C. We arrive at the same point as we go from A to D. What will be vector? What will be the vector of FA? What will be vector FA? F how we can find vector FA?
F plus G plus H.
Yes. The F plus G plus H. Make sense? Okay. Now let's consider a couple more examples before you will start working by yourself. So let's consider. That's from your booklet, page page 5, example 3. We have triangle A, B, C, A, B, C. And we have that point, point M is midpoint of AB. M is midpoint of AB, and we have N is a midpoint of AC. And let vector AB equals A, and vector AC equals B. And what will be vector CB? So vector AB is A, vector AC is B. What will be vector CB?
A minus A.
A minus A.
Vector CB will be
A minus
A minus B. Because vector CB has to be vector AB minus vector AC. It should be difference of the vectors, you see. AB, we have B end, minus AC, C is the beginning of the resultant vector. So that will be A minus B. Now, how we can find vector Mn? We need to find vector Mn.
B minus A all into.
Yes, but how we can derive that? So, vector Mn will be equal vector, this vector, Mn will be vector An minus vector Am. Make sense? Vector Mn is vector An minus vector Am. Make sense? This vector Mn is this vector minus this vector. And what is An? An, because it's a midpoint, this is a half of B. Because vector An is a half of the vector AC. It has same direction, but half of the length. Minus, what will be Am? Half A. Minus 1/2 A. We can take 1/2 as a common factor, so 1/2 of B minus A. Make sense what we did? And it's one example. Now turn next page, page 6. This is super typical type of question. When you have a parallelogram and you need to find quite a few things. So we have parallelogram OABC, OABC, OABC. And also we have M, midpoint of AB. And we have that's all what we have at the beginning. And we have that vector OA named U, and vector OC named B. And first question is find express vector OB in terms of U and B. What will be OB equal? You should be able to tell it straight away.
B minus C.
Vector OB will be vector U plus vector B. Remember parallelogram rule?
Why? Okay, I'm confused.
If you move vector V
Yeah.
here,
Yeah.
we will have this and this, and that will be sum of them. If it will be minus, then we need to change direction of one of them.
Oh, if it's minus, they don't have the same direction.
There will be different direction, different starting. So OB equals U plus V. Now need to find vector OM. How we'll find vector OM?
Is that U plus V over 2?
Yes, vector OM will be U, and clearly vector AM is a half of the vector V because it's a midpoint, so U plus 1/2 V. Make sense?
Yeah.
Next, we need to find vector CM. We need to find now vector CM. So, how we can find vector CM?
It's just
Negative G plus.
Let's do it in terms of the letters first. Let's do it in terms of the letters. So vector CM will be sum of which vectors? CB
yeah.
plus BM. Does that make sense? We get vector CM is a CB plus BM. We arrive at the same point. And what is vector CB?
U.
It's U. And what is vector BM?
V over 2.
Negative.
Why?
Direction. V is this direction.
Yeah.
BM is opposite direction. So we'll have U minus 1/2 V. Make sense? What else we need to find now? P is the point on CM. This is the point P. And CP equal 2/3 of CM. Equal 2/3 of CM. By the way, we don't know yet that it will be on this diagonal. So I will remove this diagonal, so not giving hint what we will prove later on. So we have point P which divide vector CM. CP is 2/3 of CM. And we need to find CP, what that will be.
2U13 minus
So-
215.
So we can do CP is 2/3 of CM, but we just found CM.
Yes.
We just found CM, so it will be 2/3 times U minus 1/2 V equal 2/3 U minus
I thought it
1/3 V.
So I thought it was 213. Yeah, that's fine.
So we already found CM, so we just substitute it here. And we got vector CP, vector CP in terms of U and V. Does that make sense what we did?
Yeah.
Now next, find vector OP. Find vector OP. Find vector OP. And vector OP, how we can find vector OP?
V plus C.
Well,
OP, let's do it in terms of the letters. I mean capital letters. We can go OC plus CP. To get from
Yeah,
O
like
to
the
P, we go OC.
I don't get how you know which to do plus and which to do minus.
Depends in which direction we go.
Okay.
If we will need to find vector PO,
Yeah.
then we will need to use negative directions, minus. In this case, we don't need because we're going always.
So if they're going the same like this way,
Yeah.
then what if I this is plus?
No. that will be plus this way, minus will be there.
Wait, these two vectors are going in the same direction.
If we have this vector A
Yeah.
and we have vector B, and we make parallelogram based on this, we will have this vector will be A plus B,
Yeah.
and minus, and this vector will be A minus B. This is A plus B, this will be A minus B.
Flip the direction of the
And flip in direction of the B, and we get negative B plus A, which gives us this vector. Copy this diagram, it will be quite useful to use it.
So wait, what direction is the B going now that it's A minus B? Same way?
No, B still going that way.
Yeah.
B still this direction, but minus B will be this direction.
Yeah.
That will be minus B. Minus B in the opposite direction. Okay, getting back to the equation, so we find in OP, to get to P from O, to get to P from O we go to C, OC plus CP. And be using what we have found before. Vector OC is V plus CP plus 2/3 U minus 1/3 V, which becomes V minus 1/3 V is 2/3 V plus 2/3 U, and equal, we take 2/3 as a common factor, V plus U. And what is the vector V plus U? It's OB. So you get OP equals 2/3 of OB. 2/3 of OB. So, in B, so we can say, question is, ratio of OP to PB. What will be the ratio of OP to PB? And this is 2/3, this is 1/3, so it will be 2 to 1. Okay, so that's the basics of the vectors and operations with the vectors. Now you can do some practice. Like, subscribe, and donate to help fight terrorist countries and organizations like Russia, Iran, Hamas, Hezbollah, etc. Support Ukraine and Israel.